effect. And when compared nicotinamide and then NR and NMN is consistently rescuing neurodegeneration much more evidently and in a much more statistically significant way than NR. But again, when it comes to actual supplementation in humans, we always need to be mindful of, okay, what else might be leaking you NAD, right? When you supplement orally, it's basically being broken down and secreted via urine. And in order for this process to take place, you need a methyl group. It's beneficial to supplement with trimethylglycine as well when it comes to the maximum effects of such longevity supplements.
Dr. Seranova, welcome to the interview.
Yeah, thank you for having me.
Of course, I'm very excited about today's chat. We are going to go into NAD, cognitive health, brain health, a topic that we share mutual interest in. So I'm excited to speak with you. You have a bachelor's in psychology, then you have a master's degree in translational neuroscience and PhD in stem cell biology. You published papers on several peer-reviewed, highly appreciated journals, and you have founded an anti-aging supplement company. Basically, you have quite a big selection of different kind of methods of preserve longevity and also boost NAD. And I want to discuss today about some strategies and everyday things that we can do to preserve NAD, and also the specifics on how does it relate to brain health and cognitive health and cognitive aging, maybe. So let's start with brief overview on what are NAD plus and NADH and what's their role in brain health and brain longevity.
Yeah, absolutely. So NAD plus is what we call the master regulator of human metabolism. So NAD plus is the oxidized form of the NAD molecule. And then we have the NADH, which is the reduced form with a hydrogen atom attached to it. So collectively, we refer to those two molecules in the cell as NAD pools, basically. And they both are needed. So NAD basically sits on the Krebs cycle. And without it, our cells cannot produce energy, cannot produce ATP. So if our levels of NAD would drop to zero, we would be dead in 30 seconds. So this is how important it is. And besides the energy production function, it's also implicated in over 300 enzymatic reactions in the cell, including being a substrate for different kind of enzymes, such as, for example, the DNA repairing PARP enzymes and the sirtuin enzymes that are called longevity genes as well. And then also other clusters and other functions that are less known. So, for example, a fun fact that not many people know about is that NAD also serves as a substrate for dehydrogenase. So this is an enzyme that is actually breaks down alcohol in our liver.
Okay, so if your NAD levels are low, you get worse hangovers.
Absolutely. And subsequently, if you boost your NAD levels, you will have less hangover.
Well, yeah, that's something that I didn't know for sure. And okay, so
yes, so basically, there are all these functions going on that NAD pools are supporting and NAD is crucial for. And what happens is that the production of NAD and the concentration of NAD in our cells kind of peaks at the age of 25, which is around the same age where our hormone production peaks. So actually, the process of aging, we can say that it starts at around the age of 25. And then by the time you're 26, 27, 28, you actually start feeling decreased energy and focus and brain fog and all of the symptoms. And this is tightly correlated to the fact that your NAD levels start declining. And when people actually ask me what I do, and what is NMN, which is our best-selling product at NMN Bio, and I start explaining to them that NMN boosts NAD, and then I tell them that actually, it starts declining after the age of 25, and this is why they feel fatigued. No one single person has disproved me so far at this statement, and no one has told me, oh, you know what, no, that is not true for me. Like, I'm not feeling tired, or I don't feel any different at 27 if I compare myself to 5 years ago. Not one single person. I probably made this statement thousands of times over the past 4 years or so. So this is very interesting. It's a universal kind of phenomenon that we see all people going through. However, there are multiple strategies that we can implement in order to maintain optimal health and NAD levels. With regards to brain health and cognitive aging, there are a couple of things here. And besides NAD levels, I think what's also very important is to also understand that our nutrition plays a key role in how our brain is going to age. So we have some foods that are, for example, very nutrient dense, which is basically, natural foods that are not ultra processed and probably not carbohydrates as well. So the most nutrient dense foods are protein and fat. And when we don't consume enough of those, the cognitive function and the cognitive capacity of a person is definitely decreasing. With regards to NAD, specifically, something that is worth noting is that besides thinking about how we can boost our NAD levels, either with supplements or with exercise or with other interventions, it's also important to basically think what is draining our NAD levels, right? Yeah. So I just mentioned dehydrogenase. So basically what happens when we are drinking frequently, for example, your dehydrogenase will be draining your NAD levels, right? And this is not very good for your brain because, as we will explain a bit later, there are multiple processes related to basically neurooxidation and neuroinflammation going on in the brain, and this is something that piles up as we age as well.
Yeah, thank you for the overview. I really like that you brought up that, because alcohol is a big topic at the moment. There is like certain data that shows that, maybe one drink every now and then protects you from heart disease. Maybe I believe it's mostly due to stress reduction effect, but it kind of counteracts of what it does to the brain. So we can still, I think, quite reliably say at the moment that even one drink is gonna to harm for the brain, even though it might be like reduce your stress levels in a short term. So anyway, very, very good point of you. You just said that at 25, the NAD kind of peaks and then it drops. So would you say 25 would be the age when we should start mindfully boosting our NAD levels, whether it's a lifestyle or whether it's supplements?
Yeah, so I think that it's very important to actually keep that in mind. And when we're talking about supplementation, there are obviously other nutrients that we need and other, molecules that are very good to supplement with. For example, even in sunny countries, we see people that have a high percentage of vitamin D deficiency, right? And vitamin D is crucial for our immune system and for multiple other processes in the cell. So this is something that I would definitely recommend everyone to supplement with. With regards to NAD, I think that yes, it's a very good strategy to start supplementing maybe around the age of 26, 27, because this is when it starts going down. And this is when we're experiencing all this fatigue and low energy symptoms. And usually when people experience those symptoms even before the age of 25, this is not going to be related with NAD depletion already. It's going to be related with maybe some hormonal dysfunction or with obesity, for example, because what obesity does, it basically creates consistent low-grade inflammation in the body. So then inflammation basically counteracts our energy levels. This is how I see the more inflammation you have, the less energy you're going to have because of all of the inflammatory processes with enzymes such as CD38, for example, which is another consumer of NAD in our body. So definitely a good kind of age to start thinking about what you should supplement with, and to kind of start being mindful about the different interventions you can implement in your life around the age to 25 to 27 in order to make sure that you actually are preserving peak performance, both physical and mental, brain performance and cognitive function, and physical endurance, things like that at this age.
Right. Okay, so what is your routine? I mean, I assume you are boosting mindfully your NAD and very much focusing on that because that's your area and your company. That's what it's all about. What do you do on a daily basis at the moment? And maybe do you think you are changing the routine at one point along the years?
Yeah, absolutely. So I do take a lot of supplements myself. Last time I counted, it was 27 supplements per day. And what I usually do is I'm actually cycling some of those too. So this number sometimes is changing during the year. And what I recently started doing as well is to actually cycling some supplements when it comes to particular indications. So let's say for bone health, I would cycle some supplements like glucosamine chondroitin a couple of times a year. I would then also cycle low dose melatonin a couple of times a year, maybe like 2-3 times a year for a month, in order to to kind of get the anti-aging benefits of melatonin, because some people don't know, but melatonin is actually the most potent antioxidant for your brain that exists. So therefore it does offer neuroprotective effects, basically. And then of course I do take my own supplements. So I started supplementing with NMN actually back in the days when I was still doing my PhD back in 2019. So I was studying neurodegeneration and how the human brain functions on a dish, basically, because my PhD was in stem cell biology. So what we were doing is we were working with different kind of human embryonic stem cells, and then we would implement some differentiation protocols in order to basically turn them into neurons. And then those neurons, we would treat them with different kind of compounds, either NAD boosting compounds or others, in order to see what actually can rescue the neurodegeneration. So eventually my research kind of led me into the world of NAD metabolism. So this was very interesting because we did take an unbiased metabolomics approach to actually see what is wrong with these neurons, right? So what we saw that is that the NAD metabolism was tightly correlated with neurodegeneration, in the sense that both NAD plus and NADH were very much reduced in those sick neurons. So this is why we started treating them with different NAD boosters, such as NR and NMN and nicotinamide and even tryptophan, in order to see, okay, well, how can we actually rescue this phenotype and what happens? So I'll tell you a bit more about this in a bit, but back to your question, this is when I basically stumbled upon the different NAD boosters, and I realized, oh, wait a minute, there is actually there are some companies that are already selling some NAD boosters as supplements that I can order for myself and try out. And this was the time when I was working for like 16, 18 hours a day in the lab. So I was constantly tired. I had so much work to do because I was rushing into finishing my PhD project in time. And then I took the NMN, right? So usually, because I was always a big fan of different supplementation, you would need a few days or a few weeks to kind of feel an effect, if at all. But with NMN, I realized after a couple of days, oh, well, I'm not tired anymore and I can perform better. And, my brain is not tired either. So this was very interesting to me. And I've been taking NMN for over 3 years. Is definitely my number one supplement to take. And of course, with that, we kind of need to think about what are the other supplements that can enhance our supplement routine? Because as I said previously, inflammation is actually also a big topic that is getting more and more popular now, because it's been introduced as one of the additional hallmarks of aging recently, as the 10th hallmark of aging. So I think that there is a tight relation of a negative cascade of processes in the cell when inflammation happens. And with that, there are enzymes such as CD38, which is an inflammatory enzyme that are consuming a lot of NAD. So even if you're taking NMN, the question is, okay, well, how can you optimize this whole system in order to make sure that your NAD is not leaking, right? So, with that, something that is reducing the amount of NAD leakage are natural compounds that can actually block CD38. So such a compound is quercetin, for example, which is a senolytic agent. So it's a natural flavonoid, and it's also basically killing the zombie cells in your tissues, the senescent cells that are leaking, all this inflammatory cytokines that are activating CD38 and such. And with that, I think senolytics are wonderful compounds. We have a lot of natural compounds that are thoroughly characterized at the moment with different uses. So, for example, quercetin has been shown to improve athletic endurance, and especially, it's very important to actually take an optimized form of quercetin, because when you're taking it by itself, it's actually being oxidized quite easily, and then it doesn't perform the function that you need it to perform. So, for example, the quercetin from NMN Bio contains vitamin C and citrus bioflavonoids to counteract that. And then, of course, our new product that has launched actually a few days ago. I just got the bottle like literally 2 days ago, like the real product, because I just had a mock-up before that, and now I finally got the final result. So this is our proprietary supplement, that is called the NAD Brain, and it's basically a combination of 12 compounds. This is basically the supplement that I wanted for my own brain. And I finally have put this together with all of this compound. So all of the ingredients are blood-brain barrier permeable. And then with regards to the short-term effects, there is the proper ratio of caffeine to L-theanine that basically boosts your immediate focus and concentration. But then also I was looking at the different hallmarks of aging in the brain and what makes your brain deteriorate, right? So what we're seeing with age is that the vasculature starts, decaying in the brain as we age, right? And then we have things like vascular dementia and such. And then we also have accumulation of reactive oxygen species. So there is no doubt that compounds that can have an antioxidant role in the brain are very important for us. And then, of course, we have some compounds that basically preserve the NAD in your brain, such as Apigenin and Fisetin. So Apigenin is blocking specifically CD38, and it is also blood-brain barrier permeable. And then Fisetin is another senolytic that is shown to have neuroprotective effects specifically in the brain. So there is a human clinical study on this, which was very interesting to see. And then, of course, we wanted to optimize the absorption and the delivery. So we have things like phosphatidylserine in there, which is basically aiding the other ingredients to get into the brain more efficiently, just like vitamin B5 that we also have in the blend. And then, of course, things that would be supporting your long-term cognitive function at low dosage on a daily basis, such as a small concentration of zinc and such. So it's a very, very thorough approach to your brain health. And this is, I think, this will become, my new favorite supplements now.
Yeah, it's kind of a great place when you have your own supplement company and you're also a researcher, so you can like produce what you would like to eat. And I really like this approach that you have also looked at the blood-brain barrier passage, because at the moment we have a huge problem of increased rates of Alzheimer's, dementia, and dementias in general, and brain aging is a big issue. Especially, I believe this is going to be even bigger after this pandemic that we have had, which causes neuroinflammation. And the medicines, the drugs that we have to treat brain, the issue is that for those who are maybe not that familiar with blood-brain barrier, is that we have this like protective barrier that protects our brain from the compounds, harmful compounds, toxins to enter the brain. But unfortunately, this blood-brain barrier also blocks majority, like 95% of the pharmacological drugs that are developed to counteract some aging-related diseases and even brain aging. So this is yet a quite interesting clinical issue that we have, and developing drugs that can reliably go to the brain and actually counteract the brain inflammation is at utmost importance at the moment if we want to proceed, and when we want to proceed with brain health supporting and clinical healing of the brain, if that's a proper term to use. Okay, so let's look at your research, because that was a very interesting paper, and you technically were able to show an important process, autophagy, which when goes awry will cause decline in NAD. So can you tell a little bit about your findings? What's autophagy? What does it do in the brain? And how does it relate to brain levels of NAD?
Yeah, absolutely. So as I mentioned, my research project kind of started with human embryonic stem cells. And what we actually did is we genome engineered an autophagy knockout cells. So this means that we kind of made sure that there is no autophagy initiated in those cells to start with, which is actually quite hard to study in living organisms, because what we're seeing in vivo is that those mice, for example, they have difficulty surviving, and therefore we actually can't even study them. However, at a cellular level, we are able to study autophagy knockouts, and this paper that you're referring to from my PhD work in Cell Reports is actually like a proof of principle, basically. And we hope that these cell lines that we created will be a platform for other researchers to study autophagy deficiency as well, because the beauty of stem cells is that you basically can differentiate them into any kind of cells you want, right? So what we did is we genome engineered at the human embryonic stem cell level, and we knocked out APG5, which is one of the genes that is responsible for autophagy initiation, and what we call
I'm sorry to interrupt at this point, but let's go a little bit back just to review briefly what's autophagy.
Yeah, sure. So autophagy is basically the intracellular mechanism that cells use in order to get rid of any dysfunctional mitochondria, any aggregate-prone proteins that might be floating around the cells, which is something that we specifically see a lot in neurodegenerative diseases. And basically, it's the mechanism, the junk disposal mechanism of the cell, right? So it basically contributes to the quality control of the proteins, the quality controls of the components within a cell. And therefore, it's very crucial, and especially for cells that are not proliferating anymore, such as neurons, for example, right? So they are post-mitotic, they can't reproduce anymore, so they're just sitting there, and therefore, because they don't divide, they need to be relying on autophagy to kind of clear out the different kind of junk that is floating around, and to basically recycle the cellular components and break them down into individual amino acids. And then this is this is how the dysfunctional proteins are being recycled back to amino acids, and from those the cell can build again new components. So it's a very interesting process, very crucial. And what we're seeing is, as I said, with animal models, it's very hard to study because when there is no autophagy going on, it's very hard for the organism to survive, because then you just have all this junk floating around, and a lot of functions are being impaired. So this is what autophagy is. So this is why we created the autophagy knockout stem cell model. And therefore, we then proceeded to differentiate those neurons into those stem cells into neurons, basically to study neurodegeneration and to study what is dysfunctional in those kind of autophagy deficient neurons, right? So what we did is we applied an unbiased metabolomics approach to see what are the metabolites that are perturbed in those cells. So we basically compare the autophagy deficient neurons with what we call wild type neurons, so the normal neurons that don't carry this mutation. And what we've seen is there were a lot of metabolites related to the TCA cycle being perturbed. So those were the levels of ATP and ADP and NAD plus and NADH that were extremely low in the autophagy knockout neurons when compared to control, right? So this made us think, okay, well, it looks like something is wrong. There is some sort of metabolic defect here in those cells. So this is why we wanted to kind of study it a bit more. And then we did a couple more experiments to basically see what is the uptake of different amino acids in those cells. So usually when you grow cells, you have them in what we call medium. So this is a liquid, and we provide different kind of food for those cells in this way, right? So amino acids, things like that. And then we can measure an uptake of amino acids and other ingredients. So what we realized is that actually the glucose uptake in those cells are extremely high. So glucose is a molecule that is eventually serves as an input into the Krebs cycle. So this was very interesting because despite the fact that the outcome of the Krebs cycle was completely depleted with ATP, ADP, and NAD plus and NADH, the input was so high. So we said there is definitely some sort of mechanism here. So those cells are trying to compensate for the fact that the Krebs cycle is not working. And then we wanted to see whether this cell death that we measured in those cells is actually being rescued by different amino acids. So we fed them different amino acids and we saw what the results there were. And we actually saw that tryptophan is an amino acid that is rescuing those neurons from cell death. So this was again pointing out to some sort of a defect in either NAD metabolism or NAD processing, because tryptophan is serving as an input in the de novo pathway synthesis for NAD. So this was very we saw so many different pieces of evidence kind of leading us into this direction of NAD metabolism. And this is what I meant when I previously said that when I started my PhD project, I didn't even know what the outcomes would be, right? So I thought, it would be a project on neurodegeneration and how autophagy can contribute to neurodegeneration. But then we started seeing all this evidence that were basically telling us, okay, you need to look at NAD metabolism. You need to look at, what else is going on and how you can save this, how you can rescue those cells. And therefore, we started feeding those cells with different NAD boosters, as I said. And, in research, usually what happens is that some things work and some things don't work, right? And sometimes, we just would not publish the negative results because they don't lead anywhere. So actually in the initial stages of our project, we were treating those cells with NAD boosters, but also we wanted to see maybe there are some other compounds that can actually rescue this phenotype. So we were thinking, okay, maybe some compounds related to, let's say, mitochondrial health, such as MitoQ, which is another supplement, right? So we actually treated the neurons with MitoQ and it had an adverse effect. So we were very surprised. So this
adverse effect.
Yeah,
just to clarify, this means that it did more harm than good.
It actually killed all the neurons.
Oh, okay.
And then we discontinued this compound from our experimentation, and we actually didn't publish it because there was no reason. It looked like this was a dead end. So because we also saw at the same time how well the NAD boosters are rescuing those neurons, and then we can see that even even when there is no autophagy in the cells, because this is a genetic model of autophagy deficiency, right? So there is nothing to rescue the autophagy because there is no autophagy to start with, but still we did have this rescue of the phenotype just with the NAD booster. So interestingly here, we were looking at how those things are connected, how autophagy or lack thereof is connected to the NAD metabolism. And then, we kind of dug deeper into the mitochondrial function and what is happening in those cells. So what we found was very interesting, because we found a link that were basically linking the fact that autophagy is deficient with what is happening downstream when it comes to the mitochondria. Because so the picture here is that you have the cell, so it's degenerating, right? It's not feeling very well, and there is no autophagy. So autophagy cannot clear any junk that is floating around. So this also is applicable to dysfunctional mitochondria that are floating around. And what we're seeing in dysfunctional mitochondria, and in this case we also tested, is that there are basically a lot of mitochondria in the cells, but they're not functional because they are depolarized. So the mitochondrial membrane potential is not polarized properly, and this means that there is basically a leakage of reactive oxygen species in the cytoplasm from those dysfunctional mitochondria. So now the cell is basically entering a negative feedback loop where you have all this junk floating around, you have all this mitochondria, they're not doing their work, they're not producing enough ATP for the cell to function properly, and they're leaking a bunch of reactive oxygen species in the cytoplasm, which is damaging for other cellular components, right? Because what reactive species do is they just go and they just scratch other components of the cell, and they produce more dysfunction. So then when this happens, eventually you will also start having accumulation of DNA damage in the cell because of the reactive oxygen species, and therefore
that
you
like
now
the cell
have
death eventually.
Yeah, exactly. So now you have increased cytotoxicity, and because of that, because the cell is trying to survive, you will be having hyperactivation of enzymes such as PARPs and sirtuins that need more NAD, and so now the cell keeps on spiraling, and it basically leads to neurodegeneration. So this is what we discovered, which was very interesting. However, what we've seen that even with this kind of like negative feedback loop, even when we let those neurons grow for a few weeks on a plate, and then they've already entered this negative spiral, if we do treat them with NAD boosters, they will be rescued. So this was great. And
I'm sorry to interrupt. I just want to do a little recap here. Up until now, before we go into how to boost the autophagy and rescue some of these dying neurons that we definitely would like to do, preferably to counteract any cognitive aging or Alzheimer's or brain fog, is that so we have a dysfunctional autophagy in the brain cells, which leads to lower energy production in the brain cell, but they are still utilizing more of the precursors for energy. They are still not producing energy. They're still not able to save the cellular function, and the cell is kind of going into a death processes with that. But you also found that there are certain supplements that we can feed the neurons that can restore the autophagy, so we get more functional cell and get them away from this downward spiral. And you were looking into, maybe you can go through what specific supplements you were looking into, and how do they counteract this NAD depletion in brain cells?
Yeah, so specifically with our research, we were looking into different amino acids, and we realized that it looks like if we feed those cells with tryptophan, they are actually being saved as well, along with the NAD booster. So this was very interesting. However, to my disappointment, when I looked into other studies, such as animal studies and human studies, this finding actually doesn't correlate with what is happening into humans for tryptophan in particular. And I think that this is very interesting because there are multiple steps for tryptophan to be converted into NAD in the first place, right? So there is like 7 or 8 steps, something like that. And therefore we're looking into, okay, well, what else can we do in order to boost the NAD levels and rescue the phenotype? Unfortunately, in those cells, because autophagy cannot be initiated, you can't save the actual autophagy, but if you can make the cell function well regardless, that's a win, right? Because what we're seeing in patients in neurodegeneration, I think in a vast majority of neurodegenerative diseases, from Alzheimer's to dementia, to multiple sclerosis, to all kinds of neurodegenerative disorders, they all have deficient autophagy. So they all have low levels of autophagy in the brain. So we're seeing this with biopsies, we're seeing it with different kinds of assessments. So we know that even if we have a patient who has low levels of autophagy, there might be some other strategies in order to boost it. So as I said, with tryptophan in particular, it doesn't look like this finding translates into humans. But with NAD boosters in particular, so we did test a few compounds, and what we did is we also wanted to dissect the pathway there. So we have the so the other pathway basically that we have that it is basically the salvage pathway of production of NAD, which starts with with NAM, and then it goes into NR, and then into NMN, and then it boosts the NAD levels. There is an enzyme there called NAMPT that basically converts any input such as NAM into the immediate precursors of NAD, which is NR and NMN, which are more downstream, and they're sitting basically like after this enzyme on the pathway. So what we did is we kind of dissected this pathway by blocking this enzyme with a chemical compound called FK866, and then we tested if we feed the cells with NAM, with nicotinamide, will it still save it? And it looks like it doesn't. But interestingly, when you block this enzyme and then you feed NR or NMN, then it will still save the phenotype because those precursors are sitting after the actual NAMPT enzyme, right. And then they're still able to save the neurons. So this was very interesting. So we're trying to see, what is the optimal intervention. And again, like we always want to be careful when we're producing preclinical data with regards to recommendations that we can we can give, or the conclusions that we can make from our research, right? So I think this was very interesting because it did prove that, okay, this pathway, it seems to be the most efficient one in order to boost NAD levels, but also we need to be mindful which precursors work and which precursors will have the most effect. And when compared all those 3 agents, so nicotinamide and then NR and NMN, it seems like the NMN, which is the direct precursor, the most direct precursor, because it converts it to one single step into NAD, it looks like it's the most efficient one. So at least from the data that in the human neurons. So this was very, very nice to see. But again, when it comes to actual supplementation in humans, we always need to be mindful of okay, what else might be leaking you NAD, right? So then we also recommend senolytics and things like that. And of course, when you're taking NMN, I always recommend people to take TMG as well, trimethylglycine with it, because the first N in NMN stands for nicotinamide. And when you supplement orally, it's basically being broken down and secreted via urine. And in order for this process to take place, you need a methyl group on the nicotinamide. So this is why it's beneficial to supplement with trimethylglycine as well when it comes to the maximum effects of such longevity supplements.
Right. Okay. So based on all of this data, information, we have a lot. So we noticed that tryptophan is not necessarily effective for restoring NAD.
Yeah, but sorry, can I just add something else?
Of course, yeah, please do.
So with regards to NAD supplementation, NAD boosting specifically, tryptophan might not be the most efficient one. However, this again kind of leads us back to the subject of basically making sure that your cells are not amino acid deficient in general, and you're getting your nutrients, all the nutrients that you need. Because honestly, the more I study human biology, the more I realize that basically with the current nutritional standards that are extremely low and extremely, like bad, and people are misinformed about what they should be eating, like the vast majority of people out there, they are nutrient deficient, right? And this eventually does lead to disease. So this is why it's so important to be taking your calories from nutrient dense foods such as protein and fat, and eliminate as many processed foods as possible in order to actually maintain adequate levels of all amino acids. Because it's actually in the name. So amino acids is amino acids and vitamins. So when they were discovered over a century ago. So the reason why they're called vitamins is because it's vital amines, right? So it's something vital that your cells actually need and cannot survive without. So it's actually very crucial for us to make sure that we're not deficient in all of those.
Yeah, actually, and there is another very important role of tryptophan. This is kind of going into tryptophan now, but I think this is something that many people maybe don't know, because many people know tryptophan as the precursor of serotonin in the brain and in the gut as well. And tryptophan goes into the brain, but it actually divides into two different pathways. So one is to making serotonin out of tryptophan, but the majority of goes into the Novo pathway of making NAD. And in the presence of mental distress or cellular distress, more tryptophan in the brain is used for NAD to counteract the cellular distress, as we have discussed here. So technically, if you're not getting tryptophan, even if it wouldn't boost NAD, you would probably, if you are not getting tryptophan, you would be making less serotonin, taken you have any kind of mental distress, or you have inadequate intake of tryptophan, or if you have neural inflammation. So it would technically reduce your serotonin. And we can also see that declined or neural inflammation, aging, everything goes also with reduced sleep. And tryptophan is one of the main important amino acids for making serotonin, which is converted into melatonin in the brain. So I just wanted to highlight that tryptophan is super important, even if we don't see an
immediate
or animal model of immediate effect of NAD boosting with that. Okay, let's go back to NAD boosting with supplements. So you mentioned one question that I get quite often is which one is better, NR or NMN? You kind of already answered that NMN. But still there are a lot of NR supplements on the market. And what would you say is like the protocol? Is there like some general guideline for navigating with these two supplements?
So I'm obviously monitoring very closely the literature that comes out, including different human clinical trials for all of these compounds, right? Because it's closely related to my work. So what I'm seeing is that NR again and again and again in different mouse and human studies doesn't meet a lot of endpoints in those studies. And what I've seen and what I've realized also is that NR came out earlier than the NMN. So it's been around for more time, for a few more years. and it was the first NAD precursor basically that was popularized. It was NR, and then NMN came along. So back in the days, it was not clear what is the biology behind NAD boosters converting into NAD. Is there a transporter that is transporting them into the cell, including the NMN? However, after some time, we did discover the transporter that is transporting the NMN into the cell, and it does it does end up converting into NAD in one step. So basically, what is NMN, right? So it's basically a phosphorylated NR molecule, right? So it's so what we're seeing is that if you're taking NR, your body will have to do this conversion first, right, into NMN, and then it's going to boost NAD. And this is consistent with data that we're seeing in the cellular studies. So especially, in the Cell Reports paper, and I'm guessing that we're going to link, all the research links under this podcast for people to kind of see for themselves. Like, the data in Neurons are very consistent in every single experiment that we did, that NMN is consistently rescuing neurodegeneration much more evidently and in a much more statistically significant way than NR. And then when we're looking into humans, there are over 15 human clinical studies in NMN right now. And, some of them are designed well and some of them are not. And this is usually the case with different clinical studies, right? So unfortunately, we can't do anything about it. But there are a couple of studies that are demonstrating very high efficacy when it comes to both boosting NAD in different tissues, but also things like, endurance, athletic performance, insulin sensitivity in the muscle, and things like that. And then we're looking into some NR studies, and I think that the data are consistent with the data that we're seeing in the cells, that it's actually not as efficient. And I do believe that it's because of this one extra step that our body needs to do when we're supplementing with NR, which is to convert it into NMN first, so it can boost NAD.
Right. Okay. Thank you. So technically what you're saying is that both can boost NAD, but NR requires more energy for doing
NAD. I
NAD.
think so. So when you're looking into, the quantity that someone needs to take in order to achieve the same result, I actually think that NMN becomes more cost efficient to take in the long term. Because of
and
that.
Is there any specific protocol of taking the NMN in correct way? Is there something that you need to be taken with it? And is there an optimal time of the day to take an NMN supplement?
So it should always be taken in the morning, because what happens is that NAD is actually regulating indirectly our circadian rhythms, because what happens is that you take your NAD booster in the morning, and then the body is all set for the day, and then 15 hours later the melatonin production appears, right? So NAD and melatonin are kind of going hand in hand here. And I think that it's very clear that you should take your NMN in the morning. And then, as I said, I do recommend the TMG supplement with NMN, because I think it's kind of good practice to basically make sure that you have enough methyl groups in order to metabolize it efficiently, which actually also relates to the cost of your long-term supplementation, right? So you're making the most out of your NMN by adding the TMG, potentially needing less NMN because it's metabolized more efficiently with your TMG. So that's the thing there. And then with regards to the dosage, I think it's very individualized. Like, it can be individualized. There are different kind of tests on the market that you can do, like blood tests to measure your NAD levels as well, to see where you stand. But the general rule of thumb is basically you need to see how you feel on, let's say, 500 mg of NMN after the age of 35. Start with that, and then see whether there is an effect or not at this dosage. And most people will have some sort of an effect, but if you don't see an effect, of course, you need to ask yourself again, like, what's draining my NAD levels, right? And then, of course, like, if you don't see an effect, like, you can increase the dosage as well. So in human clinical studies, it's shown to be safe after 1.2 grams a day, although I personally know a lot of people that are taking much more than that. And then before the age of 35, so someone who's 27 years old and is just starting out with NMN, I would recommend around 250 mg to start with and see how they feel. And in most cases, it will be sufficient.
Thank you so much. That was very good overview. Maybe just last question. Briefly, we have discussed so much about NAD, NMN supplements, but as you said already at the beginning, there is so much that we need to take into consideration when we consider our long-term brain health and our brain longevity. So a few tips on what do you do to optimize your brain health outside of NMN and NR supplements and NAD boosting supplements?
Yeah, absolutely. So there are a couple of things that I've discovered recently for myself, and it's free for everyone to use. And it's just amazing. It's something that basically can give you more deep sleep on demand, like how amazing this is. So this is a frequency that you can find for free on YouTube or on Spotify. Is the 40 hertz frequency, 40. And what it's doing is basically tricking your cells into thinking that you are in deep sleep, right? So what happens is that your microglia, your helper cells in the brain that are responsible for clearing the toxins between your neurons, are basically being tricked into saying, okay, well, it looks like we're in deep sleep. We need to do the housekeeping function now. We need to, clear the gray matter. So that's what they do. That's what they proceed to do. So they need 15 minutes to synchronize 1-5. And then after that, they need another at least like 20 minutes to do their job. And it's very interesting how this works. So for me, basically what I do is I wake up and then I put my headphones on. And while I'm doing some work, like I'm walking around, I'm having my coffee, I'm writing emails, and I just listen to this frequency. And after a few minutes, I actually forget that it's there. So it's just the background noise. And then 2 hours later, I'm realizing, oh, okay, well, I forgot that it's there, right? And what happens is that like your brain is functioning completely differently with such a big boost in deep sleep time, right? So I'm a light sleeper. So usually I log in somewhere between like 1 and 2 hours of deep sleep. I think the highest that I've seen it going was something like 1 hour and 47 minutes, but this is not the standard at all. So the standard for me would be probably something around 1 hour, like 1 hour and 10 minutes, something like that. So if I can have an additional 2 hours of deep sleep on top of that, like my brain is never tired anymore, right? So this is absolutely amazing. I love this. And this was basically life-changing for my brain. Another one is something very simple, but I actually had the chance to measure it this year, and I realized how important it is as well. So my work is quite challenging, quite demanding, because the company is growing so well. So, we started back in 2020, and now we're selling into 70 plus countries from our online stores. And also we are the first and the only brand of NMN being sold in the retail stores and pharmacies here in the Middle East, because we got a distribution with the biggest pharmaceutical conglomerate in the Gulf countries, and we're selling our NMN here in stores. And with that, I've been crazy busy for the last 2 years, right? Like the amount of work is just insane. But this means that during my day, like I might be having some meetings, I might be having like very stressful days where I need to be assertive, I need to be making decisions, and this is very tiring for a human brain. Right? So what I started doing recently is that between my meetings, I would basically meditate for 10 to 15 minutes, and I'm referring to guided meditation. So there is an app called Aura, for example, that has wonderful guided meditations, and you don't need a lot of it. You don't need a huge investment of time. You only need 10 to 15 minutes. And what happens is that I'm then measuring my biometrics. So I also use an app called Tori. I don't know if you're aware of it, but it's basically is measuring heart rate variability and a bunch of other metrics. And as a result, you actually can see whether your sympathetic system or your parasympathetic system is dominant. And what I'm seeing with just meditating 10 to 15 minutes between my meetings is that I switch from the sympathetic state to the parasympathetic. And this is also a game changer for me, because when you constantly need to be basically very assertive during your day, like you need time to relax as well in order to not to go into a burnout, right? So that's another one. And then finally, like we talked about autophagy, and basically you can start having some autophagy benefits with intermittent fasting, and it depends on how much of an intermittent fasting you're willing to do. But for me, I cycle it as well, just as I cycle my supplements. So I wouldn't do intermittent fasting every day now, although I used to, because I started both low carb and intermittent fasting back in 2019. And then now there will be some days within the month that I will be having, let's say, a 6 to 8 hour feeding window, but there will be other days where I would be having just a 4-hour feeding window. So this means that I'm getting 20 hours of fasting. And by that time, there is some sort of baseline autophagy going on in the liver and perhaps other tissues. So I do get the benefits as well. And we actually launched our NMN Bio mobile app recently as well. And what we have there is we do have an intermittent fasting tracker that people can use in order to measure their fasting. And also we have a few well-being questionnaires in the app, as well as, access to exclusive offers, new products, things like that. So I would also recommend people that are interested in tracking their health to download the app for free and use it.
Well, thank you so much. I'll definitely check the app as well. And at the end, maybe you could share where people can find more information about your products, your education, everything related to NMN Bio and your research.
Yeah, absolutely. So our website is nmnbio.co.uk. So we have a lot of blog posts on the website, besides, our products obviously being available. With regards to my research, just by Googling my name, you can see the Google Scholar link. It's, we can probably also link this down below, and people can find me on LinkedIn and Instagram as well, is Dr. Elena Seranova. And, I'm trying to be consistent with my social media in order to be able to provide also, all kinds of, health tips and things that I'm really enjoying studying myself.
Thank you so much.
Thank you.